Hello everybody, welcome to section 3.5 on rational functions, and in this section we're looking to do several things. First of all, you should be able to find the domain of a rational function. We've basically already dealt with this, but we'll go into a little bit more detail here. We're going to determine the equation of vertical and horizontal asymptotes, and of course have to explain what those are in the first place. We also want to determine the equation of what are called slant asymptotes and detail how to find that. And finally, how to go through the process of sketching the graph of a rational function. So we do need to start with the definition, as always. We're going to start out with the definition of what a rational function is. And a rational function is the kind of function where if you have p of x and q of x that are polynomials, then a function f of x is called a rational function if we're taking the product, or the division, the quotient of these two polynomials, p of x over q of x. The only thing that we have to make sure is that we don't choose any values for q of x that are equal to 0. So we want to exclude values that make the denominator 0. For example, we're given f of x is the rational function x squared minus x minus 5 over 2x cubed plus x squared minus 15x. And if we're interested in the domain, regardless of however else this function might be reduced, we definitely want to be able to find the domain by finding where the denominator, and in this case 2x cubed plus x squared minus 15x, squared minus 15x is equal to 0. As the statement above says, the domain of f is the set of all real numbers except those for which q of x is equal to 0. So we're just going to find those values, in this case by factoring. And we'll note that we can factor out x right away. We don't have to go through all the rational zeros test or anything fancy here. So it's x times 2x squared plus x minus 15. And for factoring this trinomial, we would want to check out to see what would work. Two binomial factors in this case. I'm just going to go ahead and do the direct factorization. If you need to go back and remember how to fill in those steps of factoring, see some earlier videos on this one. Well, we're going to have two factors. One includes 2x and one includes x as the leading coefficients, and we need factors of 15 such that when we put them into our polynomial, we get positive x. And in this case, that's going to turn out to be 5 and 3 here, because if I take 2x times positive 3, I get 6x, and I get negative 5 times x minus 5x. That will end up to be x. So in this case, I'm going to find that x equals 0, right? Even if we have x by itself, that counts. We're going to take each of our factors, set them equal to 0, so 2x minus 5 is equal to 0. And x plus 3 equals 0 produces 3 zeros here in this denominator at 2x equals 5, which is to say at x equals 5 halves. And of course 1 at x equals negative 3. When we state the domain of a function like this, we should probably use the set builder notation. In this case, it's the set of all x such that x is not equal to, and I like putting them in order, negative 3, 0, and 5 halves as three values that must be excluded from the domain. We always find the domain from our initial function. That's it. Okay, so finding the domain in a rational function, we want to make sure that we've established that these are our functions. More discussion here in the next video.